Albers, Planet X researcher and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Interplanetary Climate Change, the Sun. Now, I recently watched a video by David Wilcock in which he talks about how changes in the Sun are causing changes in the solar system. In this video, David shared many interesting scientific details about what has been occurring with the Sun, which strongly correlates with what I believe is the timing of the arrival of the Planet X system of stellar cores in the solar system, and what I have discovered about their interactions with the Sun. For instance, David mentions that strong solar flares or X-class flares started in 1989. The first occurred on March 15, 1989, and it was an X-15 solar flare. It was followed by a huge CME or coronal mass ejection on March 10th, which caused Earth's magnetic field to tilt by 8 degrees. Ever since then, there have been several X-class flares. The last one occurred on June 9, 2017. That one was an X 9.3 solar flare. And here we see an image of the protons leaving the surface after this, as the solar flare was occurring. There's usually acceleration of particles. Particles leave at extreme high speeds. So these would be relativistic protons leaving the Sun on that day, March 6, 1989. Now, I have discovered that it is the presence of stellar cores in the Sun's corona that leads to such energetic solar events. The stellar cores actually provoke the Sun into having solar flares and CMEs. This is the reason why they are so often observed within CME material. It is as if they supercharge the surface of the Sun below their position, which then results in these super energetic events, which cause the emission of high energy radiation, the acceleration of protons to relativistic speeds, and also often results in large amounts or coronal plasma leaving the Sun. Comets moving through the inner solar system have a similar effect on the Sun. The Sun is seen to release CMEs in the direction of comets. Comets, as James McCanney has shown, draw a current of electrons from the Sun's corona, and thus the explosion of CMEs from the Sun's surface must be associated with the intensity of this current flow. Thus, stellar cores must also draw an electron current from the Sun, which provokes it into releasing radiation and plasma in the form of solar flares and CMEs. And this is comet Arand-Rowland, which passed through the inner solar system in 1957. And as you can see, it has a sunward spike. This is not always seen with all comets, usually only when the electron current coming from the Sun's corona is especially strong. But the current is always there, it's just not always visible. So the effect that these comets have on the Sun has to do with this current that they draw from the Sun's corona. And here we see stellar cores in the Sun's corona. And this one definitely seen moving away with CME material, moving away from the Sun. And this one seen also within CME material, also moved away from the Sun. This one is from July of 2017. As you can see, it's a huge object about the same size as the Sun. So these are stellar cores that are attracted to the Sun and have come to the Sun to draw energy from it. But they do not behave like normal solar system matter. They do not obey normal gravitational laws. And this becomes obvious when you start observing them. And for more details on that, You may look at Article 210 entitled Stellar Core Gravity, Tidal, and G is not constant. They do, however, seem to draw energy in the form of photons and plasma from the sun, as well as electrons, which shows that they are energy depleted. A good analogy is that if a cold object comes into contact with a hot object, then heat energy flows from the hot to the cold object. Thus, the fact that the stellar cores absorb energy means that they are low in energy, and also that this low energy state leads to their low gravitational influence or field. And this is illustrated here. So let's suppose we have a hot object and a cold object first, with no connection between the two. Now the stellar cores actually form a connection between the hot object, which is the sun, and the cold object. And because they are low in energy, energy starts to flow from the sun towards them. This heats up the surface of the sun and heats up the connection between the two, which is made out of plasma. And this means that there will be energy flowing, and therefore the fields in this plasma will increase. It becomes more ionized, it becomes more energetic, and this leads then to the possibility of an energetic event occurring at the site of energy transfer, which means there will maybe a solar flare, there may be CME, which means large amounts of coronal plasma are then able to leave the solar surface. So this has led me to purpose a new theory for gravity, which incorporates electrostatics and may thus be called electrogravity, in which the photon features strongly as both a particle from which particles with matter and with charge emerge, and also as energy contained within particles. Using this theory, I have been able to explain most of the mechanisms through which the sun produces light, solar winds, solar flares, and even how the same process leads galaxies to emit bursts of radiation, which then condense into quasars, which in turn eventually sprout elliptical arms and turn into galaxies themselves, and how this process is similar to what would cause a star to have a solar flare, and how the appearance of arms is a galaxy spitting out light which condenses into stars and planets, and is the large-scale version of a star producing a solar wind. And this is illustrated here. This would be a photon which contains particles within it. These particles have mass and charge, and when the photon moves through a region of high enough electric field, then the particles emerge from within the photon, and most of the photon energy goes into producing the mass of the particles, and the rest continues to exist as energy, photon energy within the particles. And the same process is occurring from galactic nuclei, where high energy radiation is emitted from the galactic nucleus, which then condenses into matter, and it becomes quasars, which then turn into galaxies. And this also leads to the realization that stars and planets are not that different from each other. Both are powered by radioactive decay, which means large nuclei split into two smaller nuclei. And this occurs in the solid, dense cores that exist within both stars and planets. Thus, the number of unstable nuclei inside the core of an object, a star or planet, is an energy reservoir containing the photon energy that will flow from its particles and maintain its energy status for perhaps billions of years. But eventually this reservoir runs out and the object starts changing into a stellar core. core. It starts losing its gravitational influence, and so a star would lose hold of its planets. It loses its grip on its outer layers of plasma as well, and thus expands into a red giant. Its solar wind would get slower but much denser as it lets go of its surface layers of matter. It also would become more reactive to any outside influence, leading to larger than normal CMEs. And this is illustrated here, how a parent nucleus splits into two nuclei, thus releasing energy in the form of photons, gamma rays. And these gamma rays then go into the particles of matter that the object is made out of, and thus feeds energy into the particles that make up the object. And this energy is what is being released from the sun as the stellar cores or comets draw energy from it. And this then will lead into these energetic solar events such as CMEs. So in this video I watched of David Wilcock, he also mentioned the Carrington event, which occurred in 1859, at which time a huge CME was released by the sun, which then caused the severest geomagnetic solar storm on Earth. If there had been power grids then, they would have been severely damaged. The resulting power surges were still able to cause telegraph lines to work whilst not connected. Operators got nasty electric shocks, and paper in telegraph offices caught fire. David's mention was very interesting to me because I believe that the stellar core system started coming into the solar system in 1850 and were therefore the likely cause behind the solar event. I based this time frame on the appearance of noctilucent clouds, which were first observed in 1850 and never before then. Noctilucent clouds emit light, which can only occur if the atoms they are made of are excited, which means that outer electrons move to higher energy levels, or ionized, which means that outer electrons leave the atoms. Then when the electrons return to lower energy level, or electrons are captured by the ionized matter, photons are emitted, and thus light, if in the visible range, would be detected by the human eye as coming from the clouds. And this is illustrated here. This represents an atom. We have protons and neutrons in the nucleus. We have electrons in a region around outside the nucleus. Now, whenever an electron absorbs a photon, and that means the atom itself would absorb the photon because energy is quickly shared amongst all the particles. But whenever, say, a photon would absorb energy in the form of photon, then what happens is the electron moves away from the nucleus. And that's a direct consequence of the electrogravity as I described in my theory. And that means the electron either moves up and away from the nucleus to a higher energy level, which means the atom is excited, or it may actually leave the atom entirely. Then the atom has too few electrons and it becomes an ion. It has more positive charges than negative charges. And then when this atom goes back to its lowest energy level by either the electron moving back down or by capturing an electron, then this photon energy is given off. So that would mean that this atom would be emitting light. And this is what then causes these clouds to be seen to be emitting light. Electrons are recaptured, photons are emitted as the energy process where energy is transferred from the atoms in the cloud to the stellar core matter progresses. Now, stellar core matter is depleted in energy, as I mentioned before, and you may look at Article 184 entitled Stellar Core Evolution, which explains the process through which stellar core matter becomes depleted in energy. So, when they make contact with Earth's atmosphere, photon energy flows across to them, which causes some atoms to become excited and electrons to be released and to flow to the stellar core matter. Water molecules lose energy when coming in contact with stellar core dust, entering the atmosphere, and thus cool and condense into droplets, thus forming clouds around the dust. Then, as water molecules in the clouds capture electrons from other atoms or move back to their ground state, they emit photons, which is then seen as bright color coming from the cloud. And we can see an example here, a cloud in our atmosphere, which is clearly emitting light in several different wavelengths. We can see orange, orangey yellow, pink, these pink colors, dark blue within the cloud, and that means this cloud is emitting light in these different frequencies. There's no natural mechanism within our atmosphere that would cause this to occur. It is due to the entrance of the energy depleted stellar core matter in our atmosphere that this type of thing would occur. And you may look at Article 275 entitled Planet X Debris Field Impacting Earth for more details on this process. Now, cosmic rays is another factor which is affecting our planet. And cosmic rays cause air showers of secondary but still very high energy particles in the Earth's atmosphere. And stellar core interactions have caused the sun to actually become a source of cosmic rays. Now, David mentioned one particular X20 solar flare which occurred on November 10, 2000, which resulted in protons associated to the event reaching the Earth in 15 minutes. This would mean that these photons were moving at 80% of the speed of light and were therefore cosmic rays. This suggests that the interaction between stellar core matter and the sun has turned the sun into a cosmic ray source, and that this is the interaction which is leading to the reported increase in cosmic rays detected on Earth. David reported that the sun's magnetic field has actually more than doubled since 1901. So it is not a weak solar magnetic field which is allowing more cosmic rays into the solar system. You also mentioned that ice core samples suggest that the sun is the most active now than it has been for 8,000 years. So how can we reconcile the fact that the sun seems to be emitting less light and becoming weaker? Well, the stellar core system pulls energy from the sun, which will cause it to release more of its energy reservoir. This would cause more energy to flow out of the sun's core. This would have the effect of making the sun more active initially, but as its energy in its particles decrease, so will its gravitational influence and the electric field it is able to generate in its outer layers, which is directly connected to the light emission mechanism, so that the sun would eventually emit less light. So this is illustrated here in the case of Earth. The objects also affect Earth, but the process is the same with the sun. Basically, the fact that the stellar core is drawing energy causes more energy to come from the reservoir inside the core of the object. And so more energy flows through all the layers, heating up or causing more energy to be inside the particles in each layer. And this causes increased heat in all the layers, from the magma all the way to the ionosphere in the case of the Earth. With the Sun, it will cause the surface of the Sun to be more energetic, to basically be hotter and more ionized, and therefore more active. This would lead to more sunspots to appear, especially close to where a stellar core is drawing energy from the Sun. And this will increase the possibility of a high energy event occurring in that region, close to where the stellar core is connecting. Now, the increase in the interplanetary magnetic field, which was what actually Dr. Mike Lockwood was reporting on, is likely to be a result of the increased density of charged particles entering the solar wind. More particles leave the Sun as its gravitational grip on its own plasma weakens, and the stellar core system will also add charged particles to the solar wind. In addition, the interaction between particles from the two systems will lead to increased excitation and ionization, which will in turn increase the IMF, the interplanetary magnetic field. However, the increased density in the solar wind should result in a decrease in galactic cosmic rays, not a decrease. In addition, as the Sun's gravitational influence decreases, it becomes easier for plasma to accelerate from its surface. So even more dramatic solar flare events and CMEs become possible due to the presence of the stellar cores. So even as the Sun seems to grow weaker, it actually becomes more dangerous because a solar flash, which David mentioned, becomes a possibility. A solar flash is a CME which erupts from the whole surface of the Sun, with coronal plasma then engulfing all the planets in the solar system. This type of event becomes ever more likely as the Sun loses gravitational influence and thus a strong grip on its outer layers of plasma. And here's an artist's impression of a solar flash erupting from the Sun, moving out into the solar system. And the amount of coronal plasma that would then engulf the Earth would be able to cause extreme damage to our planet, even possibly burn up the whole surface of the planet. And this is more likely to occur as the Sun weakens because the stellar cores are drawing energy from it. So the photon energy within the solar particles declines, and as that happens, its gravitational influence decreases. So the Sun's hold on its outer plasma becomes weaker and weaker. And this means that it becomes more likely that this kind of CME event will occur. And the Sun will also have phases. It will for a while decline in activity because its energy is decreasing. So the activity will decline for a while. But the fact that its energy decreases means that its hold on its own plasma decreases, which means with continued provocation from the stellar cores, it may then go into another phase of increased activity, where you may again see more sunspots occurring, and it will become more active. And this occurred actually last year in 2017, when the Sun seemed to be extremely inactive at the beginning of the year, and then later on in the year, I mean, it had no sunspots in March. And then later in the year, it suddenly became more active. Now, something else of interest which David mentioned was the fact that NASA has a pernicious bias against any changes in the local interstellar medium. And the local interstellar medium is the galactic environment just outside the solar system. And since this would be where the stellar core system would be coming from, the presence of the system outside our solar system and its approach to our solar system would cause big changes in this region of the galaxy, since stellar cores would pull energy from any matter with more energy in it than they have, and increase in temperature of any medium they move through would be likely. Thus, as the stellar core system moves through space outside our solar system, we should be able to detect changes in this medium which would affect the solar system. However, these are changes that NASA would be interested in covering up, since hiding the presence and effects of the stellar core system on our solar system, and in particular on our planet, appears to be one of NASA's most important goals, which is why they constantly point us away from the solar system and draw our attention to what is happening many light years away, whilst ignoring the huge events that are occurring in our own backyard. That is our solar system. Now, David also mentioned that it has been discovered that our solar system does not look like an egg with a long tail, as it has been proposed. Nowadays, it actually looks more of a horseshoe. So the solar system is actually here, and instead of having one long tail, it has two tails, whilst this area of the solar system is being compressed inwards. So there is actually evidence that our solar system is shrinking, and this is then also the encroaching system would compress it, and it will decrease in size due to the stellar cores that are inside the solar system and have come to the sun, drawing energy from it and weakening it, which would increase the speed of the solar wind, which would then impact the size of the solar system. So other details mentioned by David Wilcock as pertaining to the sun and the changes it is going through, which seem to be a consequence of the stellar core matter interacting with it, is the fact that the solar wind stopped completely in 1999 for a period of about 24 hours. In 2003, it was detected that cosmic dust, most likely stellar core dust, was filling the solar system. This would be coming from the encroaching system just outside our solar system, which would be also affecting the interstellar medium. And in 2008, measurements showed that the sun's heliosphere, as I mentioned, which is the bubble around the sun, which we see here, which is supposed to be egg-shaped with a long tail, which is created by the sun's magnetic field and the solar wind, and is actually the equivalent of the Earth's magnetosphere, is decreasing in size, and likely due to the compression from outside of the solar system. So in conclusion, the invasion of our solar system by the stellar core system, which I have named the Planet X system of stellar cores, has caused our sun to change dramatically and has even made it dangerous to life on Earth. And I will be writing about these effects in more detail in the next few articles. And here are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.